So in the case of motional EMF, out of velocity, magnetic field, and length vector, if any of the two vectors are parallel to each other, then there will not be any EMF induced. Reason, अगर velocity magnetic field के parallel है तो electron पे force लग नहीं रहा है. अगर velocity length के parallel है, magnetic field के perpendicular, there is a force on the electron, but that force is coming out of the plane or into the plane where electron cannot move. So in both the cases, so there is a general formula also for any general case. Electron force formula in the case of perpendicular magnetic field, we can apply that formula also. अगर electron किसी ऐसे region में है where velocity and magnetic field both are there, a general formula for motional EMF, though we will not be able to, will not be using this formula. General formula of motional EMF matlab when there is a rod, when there is a rod moving perpendicular to velocity, perpendicular to the length. So suppose if it is not moving perpendicular to velocity, there is a general direction of length vector. So in that case, it is defined as the scalar product of velocity, magnetic field, and length vector. V cross B dot L. V is the velocity vector, V is the magnetic field vector, L is the length vector. So V cross B dot L. अब ऊपर वाले दोनों cases में if we check V cross B, because V and B both lies in the same plane, V cross B is coming perpendicular to the length vector, and that's why their dot product is 0, and dot product 0 means there will not be any EMF induced. Right? बेटा ये last statement वन में आया. अगर perpendicular है तीनों, then it will be VBL. If it is in any random direction, then the formula for formula for the EMF induced is V into V into L, but it will be represented as V cross B dot L vector. In terms of vector product, scalar triple product. शायद अपने में इसमें पढ़ा हो. That's the general formula for motion EMF. अब अगर हम किसी conducting किसी irregular shape के wire के लिए देखें, I think we did this. I don't remember, but no problem. We can just quickly revise also. अगर ये कोई टेढ़ा मेढ़ा वायर होगा and it is moving in a magnetic field, then also there will be an EMF induced, and that EMF induced will be calculated by using the length vector जैसे हम force के लिए calculate करते थे. So if it is a semicircular wire or semicircular ring and that is moving perpendicular to its length, so its radius is R, magnetic field is B, but we will join. So we can join their end to end. That will be the length vector. Length vector will be 2r. So अभी length vector हो गया velocity के perpendicular. Length vector is perpendicular to velocity as well as perpendicular to magnetic field. It will be P into V into L vector. That is BVR. Out of P and Q, use the right hand rule. Middle finger will come from P to Q. So P is at low potential, Q is at high potential. EMF induced in this semicircular wire or semicircular ring will be equal to BB into R. अब ये कैसा भी shape हो, any regular shape, if it is moving in some magnetic field, suppose magnetic field this time is out of the plane, and we need to find its EMF induced. We need to find the EMF induced across the terminals of the rod. So whatever be the length, अगर ये suppose 2r है और ये r, then the EMF induced will be again BV into कैसा भी shape हो फर्क नहीं पड़ता, हमें initial point और final point दोनों को आपस में join करना है, and that will be the length vector. So by that logic, if it is a closed loop, by that laptop, it is a closed loop, then what is the length vector? If it is any closed loop and taken inside,
Zero.
moving in any magnetic field. Okay, in this second case, Bharat, which one is at higher potential out of P and Q? In this second diagram, which one is at higher potential?
सर मैं बताऊं.
Yeah, use the right hand rule. Bharat,
Yes.
out of P and Q, which one is the higher potential in the second diagram?
In the second diagram, P is at the higher potential.
Use your right hand. Use your right hand.
Mm,
Use your right hand. The index finger should go inside. Index finger should go inside, and thumb is towards left. The middle finger is coming down. Right?
yes.
Middle finger is coming downward, so that means it should be from P to Q, and the direction of EMF is from negative to positive. So that will be VQ minus VP in this.
Isn't the magnetic field outside the plane?
Oh yeah, sorry. Magnetic field is out of the plane. Correct. Okay, yeah, I didn't notice that. I changed the direction of magnetic field also. So since the magnetic field is coming out of the plane, we need to switch that direction also. Yeah, but I'll try again. I think your answer was correct. So if we put our index finger out of the plane and the middle finger left and the thumb is towards left, then the middle finger is going from P to Q. Sorry, Q to P. Yeah, because the both have changed. So Q is at low potential, P is at high potential. It will be Vp minus Vq, and that will be equal to 4 BVR. Right. Okay. Now, if there is any closed loop and it is moving in a magnetic field with a constant velocity, if it is a uniform magnetic field, then net EMF induced will be zero. अब इसमें question जो आया था एग्जाम में थोड़ा conceptually let's analyze that. So if there is a rectangular or maybe a square loop and this is moving with velocity v in a perpendicular magnetic field, the magnetic field is into the plane. So will there be an EMF induced in this loop? Answer is no. Will there be EMF induced in these wires? Answer is yes. So question कुछ ऐसा ही था, EMF is induced or electric field is induced. In wire PQ, EMF induced will be zero, and the reason is because velocity is parallel to length. Because the velocity is parallel to length vector in the wire PQ. So PQ में EMF induced नहीं होगा. SR में EMF induced नहीं होगा because velocity is parallel to length. In the wire PS and in the wire QR, both will have EMF induced. Both will have EMF induced. And the EMF induced in these two rods will be same as BVL. EMF induced in PS and QR. E will be equal to B into V into L if L is the length of this square. So So there is electric field inside PS, there is electric field inside QR, but there is no net EMF in this loop is zero. Net EMF in closed loop is zero. You understood this? So question was this, that is there a EMF induced? Is there electric field in the wire? Answer is yes, in the wire PS and in the wire QR. But overall loop, there is no there is no EMF induced because QR and PS, their EMF, their EMF cancel out each other. But this will be only and only when it is moving in a uniform magnetic field. If it is moving in a non-uniform magnetic field, then their EMF will be opposite, but not same in magnitude.
So the resultant would have like a certain
Yeah,
value.
then it is just even minus E2. We'll do that next question on that. So in a uniform magnetic field, both the wires have equal EMF. Both the wires have equal EMF, but opposite. So they cancel out each other, and therefore it is zero. But when it is in some non-uniform magnetic field, for example, magnetic field produced by a wire. If it is a magnetic field produced by a wire, suppose infinite long wire, and in that magnetic field, if suppose this loop is moving, infinitely long wire carrying current I and at a distance of R, there is a square loop moving with velocity v, side length is a. Now calculate the total EMF induced in this loop. It's moving with velocity v and the distance of that square is r. So calculate the EMF induced in the loop. This will not be zero anymore because it is not in a uniform magnetic field. EMF induced in the loop is not zero because it is not in a uniform magnetic field. At the first wire, the magnetic field is different. So let's say it is B1. Magnetic field is into the plane and that magnetic field is V1. This wire is also moving with velocity V. So this is, let's say, P, Q, R, and S. EMF induced in this wire PQ is E1. E1 will be equal to B1 times V into A. B1 is magnetic field produced by this infinitely long wire. So mu naught I by 2 pi R into V into A. This is EMF induced in this wire PQ. Wire QR and PS again will not have any EMF because velocity is parallel to length vector. The EMF induced in RS, EMF induced in RS also has magnetic field into the plane, but the magnetic field magnitude will change. At the first wire, magnetic field was B1. At the second wire, magnetic field is B2. EMF induced will be equal to B2 V times A. P2 is the magnetic field because of the infinitely long wire at a distance R plus A. So mu naught I divided by 2 pi times R plus A into velocity V into E1 and E2. These are the these are the two EMF induced. In the loop, these two EMF will be opposite to each other and E1 is greater than E2. Second wire EMF is E2, so net EMF induced in this loop. So question में ऐसा भी आएगा, what is the direction of current? What is the direction of current in this loop? It is clockwise or anti-clockwise? Yes, Vyom. What is the direction of current here? Clockwise or anti-clockwise? Vyom? Okay, he is not here. Very nice.
So it will be
Okay,
clockwise.
of EMF E1 is greater than E2 in magnitude क्योंकि E1 पास में था, E1 की magnitude greater है, so the net EMF will be in the direction of E1 and that means it has to be clockwise. जिसको हम Lenz law से भी decide कर सकते हैं because ये दूर जा रहा है. As it is going away, the flux will be decreasing. If flux is decreasing, then induced current has to increase. To increase, it will produce magnetic field in the same direction as the external. So that will be mu naught I by 2 pi r into VA minus mu naught I divided by 2 pi r plus A times B into A. And this will be in clockwise direction. So इसको हम फिर solve कर लेंगे LCM लेके mu naught I VA divided by 2 pi constant 1 by R minus 1 by R plus.
So I have a question.
Yes,
The clockwise direction means it's the south pole and anti-clockwise is north pole, right?
this will be the direction of current, which means if from the top you see, you are kind of seeing the south pole of this square. What was your question? I didn't get.
So the question was ki clockwise is south pole and anti-clockwise is north pole, right?
Any closed loop, yes, any closed loop. If current is anti-clockwise, magnetic field line is coming out of the plane, which comes from the north pole. So that phase behave as north pole. If current is clockwise, place your curl your right hand clockwise, thumb is pointing inwards, or inwards magnetic field जाती है south pole में. So that phase is similar to a south pole.
Yes, sir.
Yeah. So EMF induced in a moving closed loop, if L vector is 0, EMF induced will be 0, but only and only when it is moving in a uniform magnetic field. If it is a non-uniform magnetic field, the EMF induced will be E1 separate, different on the first wire, E2 different or separate on the different wire. But for this complete loop, it will become E1 minus E2 since E1 is greater than E2. Right? Okay.
Yes, sir.
Fine. So next EMF induced in a rotating rod. अभी हमने moving rod, moving wire, moving loop. We did all these cases. Next is EMF induced in a rotating rod. In any magnetic field, if a rod is rotating
Sir,
about, yes, beta.
can you scroll up a little for a couple of minutes?
Sure.
Sir, that's enough.
Okay. This question is also asked in JEE, the last one. When a wire is moving, it is proportional to, so that was like distance R was given to the center of this square. R is the distance for the center, so पहले wire के लिए distance हो जाएगी R minus A, and for the second wire it will become R plus.
Note,
Yes.
sir, I'm saying that I've noted.
Okay. Yeah, fine. Good. So next case is now motional EMF. Motional EMF induced a rotating rod. अभी ये जो थे ये this was because of the translation of the rod when rod is moving with linear velocity. Next concept is motional EMF induced in a rotating rod.
सर ये सबसे ज्यादा इम्पोर्टेंट है ना.
सबको सबसे ज्यादा important है. ऐसा इसी को क्यों बोला वैसे?
सर इससे क्वेश्चंस बहुत आते हैं.
Question is for a unit से बहुत आता है, electricity and magnetism. This whole unit is very important. Okay, so
Basically,
ये
12th का
this
portion
is
is important.
हाँ बेटा.
So basically, 12th का पूरा portion is important.
Yes. This is a L length rod which is rotating about an axis passing through one end perpendicular to the plane with a constant angular velocity omega. Magnetic field is perpendicular to the plane. Constant uniform magnetic field is there perpendicular to the plane which is B. So since rotation is also like a motion, because of rotation each particle will have also have velocity, and due to that velocity it will experience a force. So that concept of force will also be applicable. It is moving with velocity, angular velocity omega. So there will be linear velocity which is omega into r if the distance of that point from the center is r. V is equal to r omega. So all the electrons are moving also in this magnetic field, but the speed of different electrons will be different because there are different distance. So हम क्या करेंगे? R distance पे एक छोटी सी length लेंगे. That length is dr. EMF induced in that small length dr. EMF induced.
On which axis is the rod rotating?
हाँ बेटा.
The rod कौन सी axis में rotate हो रहा है?
About an axis passing through one end.
Okay.
P से pass होने वाली perpendicular axis के about. Axis is perpendicular to the plane. So, or you can say it is parallel to magnetic field.
अच्छा, so it's spinning like a helicopter blade.
Something like a.
So I'm still not getting किस direction में spin हो रहा है वो.
ये rotate ऐसे हो रहा है. This is rotating like this. Axis is passing through the center perpendicularly.
Okay.
So when this rod moves, each part of the rod has different velocity. EMF induced in a small length dr. Emotional EMF induced in a rotating rod about an axis perpendicular to its length. Rod की length के perpendicular है, and in this case it is also passing through one end. So EMF induced in a small length dr. Now we can apply that formula of BV into dr. So that is B into V. Length is dr. B is equal to omega r into dr. That will be EMF induced. Now we can integrate this on both the sides. So if we integrate this from 0 to E induced and 0 to L. So EMF induced will be B omega. R का integration R square by 2, apply limit. So that becomes B omega L square by 2. So if L length rod is rotating with velocity omega about a magnetic field which is perpendicular to its plane B, is half B omega L square. P और Q के बीच में that has been the EMF induced. Now we also have to decide P और Q में higher potential किसका है by using the right hand. If you apply the Fleming's right hand rule,
Sir,
yes,
sir, what is the integral constant in this expression? Don't we add an integral constant here?
yeah, maths na.
Yeah.
You should not ask this question. Then.
This is a
Then the
definite
integral
integral,
constant.
so we don't need an integral constant.
Yeah, this is different integration, man. We have put the limit.
Sir, unfortunately in my school definite integrals haven't yet started.
But fortunately, I have taught that. So again, that should not be the question in class 11th also and 12th also. जब भी हम जब भी हम इंटीग्रेशन करते हैं and we have the limits, upper limit minus lower limit, that constant get cancelled out. only for indefinite. When the integration limits are unknown, then only there will be a constant. Okay,
Okay, sir.
use the right hand rule and decide out of P and Q which one is it
सर
higher
आपने
potential.
by 2 क्यों लिया है? L square by 2.
मतलब क्या चाहते हो यार आज तुम लोग ई ओमेगा इंटीग्रेशन ऑफ आर डी आर, ये मैथ्स वाले लोगों को क्या हो गया आज? मिस्टर रुद्रांश, मैथ्स आपके पास भी है, एक्स का इंटीग्रेशन डीएक्स के रिस्पेक्ट में क्या होता है?
X square over 2.
रुद्रांश,
Yes sir.
हाँ, व्हाट इज द इंटीग्रेशन ऑफ एक्स ओवर डीएक्स?
अच्छा सर वो R L है इसमें, ठीक है
क्या
सर, वो जो
अगर
R है.
एक स्टेप मैंने थोड़ा शॉर्टकट में कर दिया तो ऐसा करोगे, आई जस्ट प्लेस द लिमिट डायरेक्टली, एक स्टेप और करके दिखा देते हैं. बी ओमेगा आर का इंटीग्रेशन हो गया आर स्क्वायर बाई 2, जैसे एक्स का इंटीग्रेशन होता है एक्स स्क्वायर बाई 2, एंड देन this is a different integration, so we'll have to apply limit from 0 to L. Start from the limit, so upper limit value b
सर एक बार L रखेंगे, एक बार 0.
हाँ,
समझ गया सर.
ओमेगा L स्क्वायर बाई 2. राइट हैंड रूल लगाना रुद्रांश, पी और क्यू में कौन सा हाई पोटेंशियल है? डिडक्शन ऑफ एमएस इज फ्रॉम पी टू क्यू और फ्रॉम क्यू टू पी? But thumb should be down because velocity is down. Yes. It is from P to Q or Q to P? Bharat?
Sir, just
Okay. I think you are placing it right way. Yes. Direction of EMF is coming P to Q or Q to P? Branch, direction of EMF.
सर Q2P.
Q to P. कैसे? निशाना करके अपना हाथ अंदर की तरफ मैग्नेटिक फील्ड है, वेलोसिटी नीचे की तरफ है, मिडिल फिंगर इज कमिंग टुवर्ड्स राइट, बट इज कमिंग टुवर्ड्स राइट, व्हिच मींस ईएमएफ की डायरेक्शन होती है लो पोटेंशियल टू हाई पोटेंशियल. So this is potential at Q minus potential at P, and that is half B omega L square.
सर I'm confused again, वो कैसे रोटेट हो रहा है? आप एक बार कैमरा ऑन करके दिखा सकते हो विद अ पेन?
These are the position of rod in the subsequent time. It's rotating clockwise. These are the position of rod after some time, instants of. Yeah. Yeah.
Yes sir.
Okay. So this is a rod. Rod is moving. Rod is actually rotating about an axis passing through end. If rod has length L, it is rotating with angular velocity omega in a perpendicular magnetic field B. The EMF induced across the length will be half B omega L square. If the same rod is rotating about the axis passing through center, if the rod is rotating about an axis passing through center, then how much is the EMF induced? So, if suppose this rod rotates about axis passing through center, there will be two parts of the rods. There will be two parts of the rod rotating in opposite direction. If the right side of the rod is going down, the left side of the rod is going up. So let's say this is O, one end is P, another end is Q. Now it is rotating about an axis passing perpendicularly through point O. Rod rotating about an axis perpendicular to plane passing through its midpoint. Right. So now if we consider this rod into two parts, one is from O to P, another is from O to Q. So O to P is moving up and O to Q portion is moving down. And if we can consider this as, let's say now the rod or length of the rod is 2L. So this is this length of rod we just assumed as 2L. We can take L, then it will be L by 2, L by 2 on other side. Because of the rotation of this rod from O to Q, there will be one EMF induced between O to Q, which is same as the previous case. So from O to Q, point Q will be at higher potential, and that EMF induced in the right half of the rod is half V omega L square. Applying the O will be at negative, Q will be at higher potential, VQ minus VO is half omega square. Now if we apply the right hand rule on the right hand Fleming's right hand rule for rod P to O, again it will be coming from O to P. So from O to P also, this is the similar case. A length L rod is rotating about one end. So this is basically considered two separate rods. One is from O to Q, another is from O to P. दोनों में EMF का formula will apply half V omega L square, same as the previous case. But if suppose we have to find the potential difference across the ends of the rod between P and Q, if we touch any voltmeter, EMF induced between the terminals or between the ends of the rod will be zero. Potential at P minus potential at Q. If we subtract these two equations, equation number 2 minus equation number 1. So equation number 2 minus equation number 1. So one equation is this Vp minus Vq minus Vo, and equation number 2 is Vp minus Vo. So equation 2 minus equation 1, that will give Vp minus Vq is equal to 0. So अगर हम कोई ऐसा voltmeter लगाते हैं जो इनके ends के across है, the reading of that voltmeter will be 0. V1 will show 0 reading. If we connect the voltmeter between the center and other side of end, which is V2, this V2 will be equal to half V omega L square. So if there is any rod rotating about an axis passing through center perpendicularly, the EMF induced across the ends will be 0. Understood? रॉड अगर अपने एंड के अबाउट रोटेट होती है तो उसमें हाफ वी ओमेगा एल स्क्वायर. रॉड अगर मिड पॉइंट के अबाउट रोटेट होती है तो एंड पॉइंट के बीच में पोटेंशियल विल बिकम 0 because both side of the rod has potential, but those potentials will be opposite, so it will cancel out each other. Right. Next case. Next case. Suppose there are multiple rods joined at one end, like spokes, wheel having spokes, and now it is rotating about axis passing to its center. A wheel having n number of spokes. There are n rods joined together at the center. There are n rods joined at the center. So outside it's like a zero resistance wire on which they slide. N number of rods, like a wheel having spokes, cycle wheel. Each rod has length L. It is rotating about an axis passing through center perpendicularly. Magnetic field is perpendicularly inwards into the plane. The rod has length L and number of rods joined together at the center and is rotating with constant velocity omega. This is the next case. N rods, each of length L, joined at the center, is rotating about an axis perpendicularly, about an axis passing perpendicularly to the center. So what will be the total EMF induced between the center and circumference? What will be the EMF induced between the center and circumference? Yes, there are a number of rods. Each rod will have an EMF induced. Each rod will have an EMF induced. And now we have to consider, we have to find what is the total EMF induced between the center and circumference. Yeah, n number of rods. Each rod will have an EMF induced, and that EMF induced will be half V omega L square. So there is a low potential and high potential. The same will be at every rod. Each rod there will be a number of rods, and each rod will have an EMF of half V omega L square. EMF induced in each rod is half V omega L square, or ऐसी n number of rods connected है. So there are such n EMFs. Now, are they in series or parallel? That will decide the equivalent EMF produced by this combination. These n number of rods, they are in series or in parallel? How do we decide they are in series or in parallel? There are n identical cells and identical EMF connected together, we need to find whether it is in series or whether it is in parallel. Now, where it is in series or it is in parallel? There are n cells और सबके negative terminals आपस में connected हैं center पे. Each negative potential terminal is connected at the center. So, is it series or is it parallel? Yes. Is it series or it is parallel? It is series or it is parallel? The n identical cells and these
So it's in parallel, right?
they are in parallel, yes. N identical cells in parallel. Identical cells को जब parallel में लगाते हैं, then equivalent EMF also remains same. Equivalent EMF induced between the center and the circumference. N identical cells को series में लगाने पर EMF एक cell के equally होता है. Equivalent EMF induced between the center and circumference is same as that of single. So, एक हो या 10 हो या 100 हो, it does not depend upon independent of the number of wires or number of rods. Identical cells को कितने भी हम connect करेंगे, all there will always be same EMF. So between the center and circumference, EMF induced will be half b omega L square, and between the end point of a diameter, it will always be equal to 0. Right? So when there is a number of rods connected together at the center and it is rotating about a perpendicular axis, EMF is induced in each rod, but each rod will be having a same EMF. One end of each rod is connected together, so it will be considered in parallel. क्या लॉजिक समझ में आ रहा है?
Yes, sir.
So if suppose such infinite number of rods are there, side by side, then what does it become? What is the shape form?
It becomes a plate,
It become a
like a circular shape.
so that is called disc, na? It will become a disc.
Yes, sir.
Right. So suppose if there is a metallic disc or any solid disc of radius r and it is rotating in a perpendicular magnetic field. This is some solid or metallic disc of radius r and it is rotated with constant angular velocity omega about a perpendicular axis kept in a magnetic field B. This is a metallic disc. If any metallic disc is rotated, if there is a metallic disc which is rotated about an axis passing perpendicularly to the center, it can be considered as the combination of such infinite rods placed side by side, and each rod will again have exactly same EMF and they will again be in parallel. Since it is independent of the number of rods in between, the EMF induced between the center and circumference will also be will also be same. So again, the EMF induced between the center and circumference. Here we can assume each rod length is equal to the radius of this disk. So there will be an EMF induced between the center and the circumference if any metallic disk is rotated with some velocity about an axis perpendicularly, and this generator is called copper disk generator, which is used in the mechanical toys. You might have used in your childhood those toys which do not require the battery. You just have a key, you fill that key, rotate that key, there is a coil, and that coil stores potential energy. That potential energy converts into the kinetic energy of a disk. Between the center and the circumference, an EMF is produced. That EMF gives the current. So small LEDs in those toys, they start glowing without the current use or without the cell being used. You understood the example? So, understood the example? जो मैकेनिकल टॉयज होते थे जिनमें हम चाबी भरते थे उनकी बात हो रही है. EMF induced between the center and circumference is equal to half V omega R square. Between the center and circumference is half V omega R square. Right? Now this EMF induced is used. This EMF induced is used for the mechanical toys. R is the radius of this disk. So without using this cell or battery, those mechanical toys have the light or have the glow of small LEDs. So that's because of the copper disk generator. It works on the principle of this motional EMF in a rotating metallic copper disk. Got it?
Yes, sir.
Okay. Now in the practical life, the daily life also, because there is Earth's magnetic field, because of Earth's magnetic field also there are a lot of things moving or rotating. They also they also develop an EMF. And that EMF is induced. That EMF induces also helps in certain way, like all the migratory birds, they are able to find the same direction or same location again and again with the help of motional EMF induced in their wing due to the Earth's magnetic field. Motional EMF induced in an aeroplane so suppose the aircraft is moving from north to south direction. So if suppose an aircraft is moving from north to south direction, assumingly this is an aircraft. So if it is moving from north to south direction, the velocity is parallel to its length. So obviously across the length there will not be an EMF induced. Across the breadth, yes. Breadth matlab across the wing span. And the Earth's magnetic field horizontal component is from south to north. So because of horizontal component, again there will not be EMF induced because velocity is parallel to magnetic field. The other component of magnetic field which is perpendicular to it, that is vertical component. So EMF induced in the wings of an airplane is because of the vertical component. EMF induced in the wings of a aeroplane. That will be equal to BV into V into L, where BV is the vertical component of Earth's magnetic field. Due to the horizontal component, never will be the EMF induced. Vertical component हम कैसे calculate करते थे? Vertical component is also B sin delta. Vertical component of Earth's magnetic. Even when it is going from east to west direction, then also there will not be any EMF induced, and the reason for that is now it will be parallel to the length of the wing.
Can you scroll up?
EMF induced is the same BBL. All the three components P, V, and L must be perpendicular to each other. Okay. Right. So even if it is going from east to west, then also the EMF induces because of the vertical component, as now the length of this wing will be parallel to magnetic field. So there will be EMF induced in the wings of an airplane, and that is because of the vertical component only in all these scenarios. Right? Okay.
Yes.
So I think now we'll continue tomorrow in the weekend batch further. That's it for today. Thank you.
Thank you, sir.
Thank you, sir.